We're going to continue working with normal probabilities. In this case, we're going to go in the reverse direction. But before we do that, we're just going to do a quick review of what we did last time. So what we have is a normal distribution curve. It says that Mr. Nichols goes fishing with his sons. He notices that the amount of fish they catch is a normal distribution with an average of 6 fish. So what we do is we put the 6 in the middle and a standard deviation of 2 fish. So that means from the middle, we're going to add 2. So that gives us 8, 10, and 12. And then on the left side, it's going to be 4, 2, and 0. Now, just as a quick review, 1 standard deviation away is 68% of the data. 2 standard deviations away is 95% of the data. And 3 standard deviations is 99.7% of the data. Now, when we're solving this, what we're going to do is we're going to look at the probability that he'll catch more than 7 fish. So z is greater than 7 minus 6 over 2. And that right there gives us 1/2 or 0.5. So if you remember, we're going to go to Desmos, and what we have is 0.5, and then what we have is infinity, and that gives us 0.309. So what we have is the probability is equal to 0.309. Now, what's the probability that they catch less than 3 fish? So this time, z is less than 3 minus 6 over 2. And that right there gives us negative 1.5. So what we're going to do is we're going to go back to Desmos. And this time what we have is negative 1.5. And so when we're looking at that, what we notice is that we have a probability that is equal to 0.067. And the last type for finding probabilities, it's in between. So we have 1 minus 6 over 2, and we have 5 minus 6 over 2. And that right there gives us negative 2.5, and we have negative 0.5. We're going to go back to Desmos, and what we have is negative 2.5, and what we have is negative 0.5, and that gives us 0.302. Now what we're doing is we're changing it around. This time, instead of it saying how many or what is the probability, we're saying how many fish. So the question changes. This time we're going to do the reverse. Instead of setting up a z, finding the probability, what we're going to do is we have the probability, 0.25, because it's the bottom 25%, and we're going to find our z value. So we're going to use Desmos again, except in this case, what we have is a different function. So we're going to add, and we're going to go to functions, and we're going to go to distributions, and we're going to do the normal CDF. And we're going to put a period, and then we go back to functions, and we go to distribution, and we do inverse. And we're going to put in the 0.25. And that gives us a z of negative 0.674. we're going to set that equal to x minus the mean over the standard deviation. We're going to times it by 2. We're going to add the 6, and that gives us 4.65, or what we're going to say is 5 fish. So this time, how many fish? So we're going in the opposite direction. So our probability is 0.9. Notice that it's not 0.1 because it's the top 10%. If you're in the top 10%, you're the 90th percentile. We're going to find our z-value. And so with our z-value, we have 0.9. And so that gives us 1.28. So equals 1.28. And that's equal to x minus the mean divided by the standard deviation. We're going to times the 1.28 by 2, and then we're going to add the 6, and that gives us x is equal to 8.56, which would be 9 fish. This time what we have is an intelligence scale, and the intelligence scale has a mean of 35 and a standard deviation of 6. So we're going to find the 65th percentile. So that means the probability is 0.65. And so we're going to find the z-value. So we type in 0.65, and we have 0.385. And that's equal to x minus the mean divided by the standard deviation. We're going to times it by 6, add the 35, and that gives us x is equal to 37.3, which we're going to say is a score of 37. Now, what number represents by the 90th percentile? And that right there, we already did 90%. It was the 1.28, so probability is 0.9 again, and that means the z-value is 1.28 equals x minus the mean divided by the standard deviation. And so x is equal to 42.6, which is a score of 43. Now we're going back to review what we did the last time because it says probability. Notice it's in between those two values. So we're putting the z in between. We have the 28 minus the 35 over the 6. And we have the 38 minus the 35 over the 6. That right there gives us the z-scores of negative 1.17 and 0.5. And when we go to Desmos and put it in, we get a probability of 0.57. And then for the last one, we do the same thing. It's in between, 41 minus 35 over 6, and 44 minus 35 over 6. And that right there gives us the z-values of 1 and 1.5. And that right there gives us a probability of 0.092.